Hello guys, today we're going to finish 1.3. Pretty much we're going to go over examples 3, 4, and 5. Now, example 3 is pretty straightforward. It's just approximate the zeros. So there's a couple of ways we can do this. The first off, and the easiest, is just visually. You look at the graph, and then you see where the graph touches the x-axis. These would be the zeros. Please keep in mind the scale so you can approximate properly. And remember, it's approximate. You don't have to be precise, but you have to be close to the actual value. So the easiest way is just visually look at the graph and see where your graph touches the x-axis, and that's pretty much how you find the z, or you approximate the zeros visually. Another way is to look at the table that you're given. And think about this. If the function is continuous and you have positive answers or outputs and negative answers, between these positive numbers and negative numbers, you have to cross the value 0. There is no way to have positive values and negative values in a continuous function or graph without going through the value 0. So when you look at a table, this one's negative, this one's positive, there has to be a 0 between this negative value and this positive value. Now, I continue positive, and I shift towards my negative value. There must be another 0 between these two. And finally, I go from negative to positive. There is another 0 there. Positive. So again, my 0 could be between these two values. You could say negative 2.5. Again, you can probably graph these and visually estimate using these values. I also should have another 0 between the x values of 0 and 1, and also 1 and 2. If you look at the graph, it corresponds to those particular values. That's pretty much example 3. Approximate the zeros visually and via table. Pretty straightforward. Next, we're going to go over graphs that approach infinity. It's a fancier way of saying end behavior. And we saw this last year, but let's repeat. End behavior is what y value am I approaching as my x approaches positive infinity and negative infinity. But now you should state your answer as we state limits. So you say limit f of x as x approaches, it could be either infinity or as x approaches negative infinity. Let's look at a quadratic first. A quadratic. Again, as x approaches infinity, positive infinity, your y value will be increasing and approaching positive infinity. As x approaches negative infinity, that's going to be the same. Your y will be increasing all the way up to positive infinity. So the behavior of graphs as they approach infinity is the exact same thing as end behavior, only now we're stating it as a limit. Limit f of x as x approaches positive infinity is this value, x approaches negative infinity would be any other value. Let's go over another example. I have an inverted cubic function. You don't care about the mid behavior, you just care about the ends. As x approaches positive infinity, my y is approaching negative infinity now. And as x approaches negative infinity, as my x is going towards negative infinity, y is going towards positive infinity. So it would be pretty much like this. The last thing that you can encounter is, and we're gonna go over horizontal asymptotes a little bit later, but when the graph kind of like squares down to a particular value and it's not exactly going down or up, you're actually approaching that particular value. And let's say I'm approaching 0 here, you would just label it as a limit. Limit f of x as x approaches positive infinity, I would be approaching the value 0. So that's pretty straightforward right there. And to the left-hand side, as x approaches negative infinity, I would be approaching positive infinity. So as x approaches positive infinity, my y is getting closer and closer and closer to the value 0, not negative infinity. Because if I were approaching negative infinity, I would just end up pointing downward and not to the right. One easy way to tell if you're approaching positive or negative infinity or a particular value is to focus on the arrow. Now, normally, these graphs, if you're approaching positive infinity, it's going to be clear that they're going upward. If you're approaching negative infinity, y values, the arrow is clearly pointing downward. Or if you're approaching a value, usually the arrow ends up sideways. And that value is the value that you are approaching. So focus on the arrow, pointing up, pointing down, or pointing sideways. It's going to tell you if it's approaching positive infinity, negative infinity, or a particular value. That's it for today. I will see you later.